Good afternoon. This will be, I hope, an IoT talk. My name is Stefano Terna. I'm the technical co-founder at TomorrowData. TomorrowData is a small and young startup working in the domain of small to medium enterprises. We do not like hypes and we do not like buzzwords. We work with real customers which have real problems, and they do not even know what IoT means. I mean, they are not required to know it. We are in charge of understanding what IoT can do in order to improve their work, their products, or whatever. But anyway, IoT is not anymore a buzzword or a hype. And let's use somehow a metaphor to understand why. We can introduce the concept of borrowing it from physics, the concept of the technology of phase transition. Namely, if you have carbon and you submit it under a huge pressure, it in some point in time it transforms into a diamond. I mean, the atomic constituent, the atom, is always the same, but the mechanical properties of the material change dramatically, and you have a completely new thing in your hand. Such a same thing, we can say, happens looking at what are kind of old versions of some technologies and what we call them now, and what happened in the middle so that they get transformed in this new version of technologies, producing new technologies, not something that is just, you can say, oh, but we do IoT since 20 years because we had embedded devices. We've always had embedded devices. Okay, no, the fact is that in any of these examples, you can put in this slide a lot of other kinds, but these are, say, the most noble one. The forces which interact with IT infrastructures or with data, or just look at embedded devices, if you think at the lowering of sensor costs, mainly driven by consumer market, if you think at the lowering of the power consumption of remote devices, and if you think at the pervasiveness of such devices, and if you think about the internet, which was not obvious that were in the play when we were talking about industrial automation, for example, then this kind of things, embedded devices and industrial automation, transform into a completely new technology, which we call now Internet of Things. This is just to say that there is something really different. And since there is something really different, this phase transitions at a point in time, with respect to which we can look at a pre-transition and a post-transition, and we can somehow inspect issues arising in the post-transition. One of them is integrating and delivering devices. Let's have a look, these are just examples, at what was done in integrating and delivering device in the pre-transition phase. Well, if the device works, just don't touch it, it is working, so don't upgrade it. Or namely, upgrade it very rarely. It costs a lot to upgrade it because, I mean, I have a lot of examples of working by myself in this field since 15 years. The customers say, well, when you plan to upgrade the device, let me know because I will send someone in case he had to raise it electrically. This is a real problem because the device won't reboot after your upgrade. You have to send someone. And if you are in an enterprise situation, this maybe can be affordable economically. If you work as we do with small customers, maybe you don't have the economical strength to tackle such situations. What the hype of the IoT says answer in the post-phase transition? Well, put your logic cloud side, so your device just is agnostic of logic. It sends messages to some cloud, to some AWS Lambda functions. They elaborate the message and get you back some response, maybe to the user, or maybe to the device itself. And so, technically, the answer is just don't touch it anymore again, because as long as you respect the protocol that you have established to communicate between your cloud and your device, you don't have to do anything. Well, this is not exactly what we like, because if the useful functions you want to implement for your customers cannot just live in the cloud. They should be implemented sometimes on the field, because maybe you have real-time high-frequency signals. You cannot just send all the signal to the cloud to be analyzed. You want to build a reliable solution for critical industrial application, and if the connection is lacking for a moment between the device and the cloud, and you expect a feedback from the cloud to produce some physical action on the device, you are not producing a reliable solution in this situation if the logic is within the cloud. You maybe want to reduce action latency and bandwidth consumption, and in fact you want to make data actionable even if the connection is discontinuous. But we have too many devices to forget about the fact of continuously integrating and delivering the firmware. So in the pre-phase transition situation, the devices were in a very little number, or you had a lot of people to manage them. Now they are too many to manage, to forget how to manage them in an automatic way. And you have always to take into account what happens if the device won't reboot, or what happens if the firmware gets corrupted during the transfer. Another issue between the pre and the post-transition is about security and privacy. So again, just to take it funny, in the pre-transition situation, just who care about small devices on his local network? You go to the customer, you install some devices on the network, and maybe the IT of that customer would have never known about these devices, would have never been aware of these devices on his network. And moreover, who knows about the meaning of the messages which have been exchanged? So security was just good security. And it is news of 1 or 2 weeks ago of a major access control producer in the world, which has something like 100,000 doors, automatic doors installed, badges which can open and unlock the doors. And a major issue has been found within the firmware, namely when they put a functionality to help the operators to find the doors after years they have installed them, and they didn't know where the doors are, which are the electronic addresses of such doors. So they've introduced back in the years a function to just switch on a LED on the controller of the door, so that the installer can know which is the door that he's looking for. And this switching on the LED is done just by sending in broadcast to all the doors over UDP a shell command, which is run under root permissions within the device, and of course if you put another command, subsequently you can execute whatever you want. And so people started playing to unlocking all the doors in the important times of morning or the evening. And this is not a small startup, this is a major industry which work in the pre-transition methodology. So just we are putting doors, and who cares about doors in the network? The situation in the post-transition is not so better. The question remains. Unfortunately, something symbolical happened in July of the last year, when Wired published an experiment, a sort of social technological experiment of hacking a chip from remote and just stopping it while this car was being driven by the journalist of Wired in a highway. And this made a lot of noise in the sector, and people started thinking about security in IoT. As for now, the first thing we can do is just apply best practices. So just do not put the same password on every device. And there are a lot of cases in which, starting from home home routers, you have the same kind of 10 passwords you can just look for. Then you can you can try to put some sort of encryption within the device. It is not easy because the device is constrained and you have to use a lot of computational effort to perform encryption, but you have to. There are also processors which with hardware support for encryption. One thing that I can expect is that it's not an IoT vertical aspect, but one thing that I can expect is that blockchain, the ledger, the distributed ledger, technological distributed ledger behind the Bitcoin phenomenon, which is now being studied not for Bitcoin, but to keep trace of the ownership of any kind of things, and material contracts or financial properties or things. So Linus Foundation started a project called Hyperledger with a lot of contribution from IBM, from major banks in the world, which are working on this. And I would expect that from blockchain, something very useful for IoT security will come in the near future. But in the meantime, we are expecting, we are not developing any kind of blockchain technology. Just let's see if going open source can help. And in fact it can, because if we look at an interoperable, secure, and privacy respectful solution for our customer, well, interoperability can be achieved if we can share among producer and developers the main building blocks. Such a widespreading of the source-based code enables cross-testing in different scenarios. Keep in mind that in IoT, your use cases are a lot. You install a device in a situation, and maybe just from your laboratory and the real case of your customer, there are a lot of differences. And maybe your security solution for the situation didn't apply, or maybe your solution don't apply for another use case. So spreading the base code for the solution of these issues would very high benefit in order to produce robust solutions. And last, well, you put your device on the internet, you connect it to some cloud, and at some point in the procedure you check a sign saying, yes, I accept that you get all the data and that you will treat my data in a secure manner. Okay, this is enough, this is good, but maybe more than this is that if the user, not all the users, but just as you know, the open source philosophy, if the user can have access to the code, this is a much stronger answer to the privacy demand. Maybe he will have some colleague, some friend, or maybe the user is a customer, the customer has maybe also a small IT that can check the fact that what you are saying about security or about privacy of this data is respected. In the code of the device is not hidden any kind of backdoor to send the data somewhere else other than what you are declaring, because the code is there and is testable. And moreover, an IoT platform is not just a program, it's not an executable. You don't run just an IoT platform. An IoT platform is an entire ecosystem of a lot of architectural building blocks. They need to be properly orchestrated together, and since we want to be open source, there are already many great open source tools that perform some of the tasks needed, but new tech issues we've spoken about need to be addressed by new kind of tools. So this is why we prefer to speak about an IoT distribution, borrowing this term somehow poetically, you can say, or not, but just as Anaconda is a distribution for data. And now you have the need to glue all these things together, and here is where Python comes. This is from previous year, Fabio Krieger, the IoT revolution, present and the future at Python 6. Because Python is expressive and agile, and it is easy to try out new key concepts. One of the key concepts we will see in the demo is somehow a sort of previous or preview of continuous integration in IoT. And maybe you have to write it down in C code for the device when you are in production, but let us try it, if it works, the overall concept, and with Python you can. Is accessible, so it is easy to prototype on both sides of the IoT pipeline, so you cannot only, a lot of IoT solutions for end users allow them to just drag some buttons on an app, and they have a beautiful graphical app with which they can do things, whatever they want. But I mean, developing on the other side is difficult also with Python, but surely it's easier than doing it in C code straightly on the iron of the device. And lastly, Python is glue. It operates at best as glue, and so we can use it to orchestrate new and existing tools, and Python is cool. So, I am proud to announce, and this, I have the opportunity here at the conference, that we are publishing on GitHub under the Apache 2 license an IoT an Internet of Things open source distribution called Iottly, with which we now do some kind of demos. We invite everyone to have a check to the code, download it, try it, test it, and let us know feedback through the usual channels of GitHub. And we will have, coming back a second, sorry, to the layout of the presentation. Now we have a live demo, and then we will have a demo on working with the source code, and we will close with the roadmap, because this is an ongoing project, so we have a roadmap. So sorry. Okay, here it is. But just to have a Python map of Python on the architecture, and so I can give you some hints on the architecture itself. The main building block of the platform, you can see from this, this is an ecosystem, it's not a single application. Everything runs on top of Docker. We choose Docker for both production and development. At this moment, production is, I mean, not so urgent, but we choose a Docker because we can share the same architecture on all the developers' laptops. So, in a complex architecture like this one, you know, here you have, don't know if you know them, but OpenFire is an XMPP chat system made in Java. It is open source. There is no need to build from scratch an XMPP server. Mosquito is an MQTT broker, so it is written in C and is wonderful, and there is no need to write another one. And here you have Tornado running as a web framework. Then you have the web server in front of all, which is Nginx. Then you have the database, which is MongoDB. Then here you have to do some stuff in Python within the web framework. Then you have AngularJS for the front end, for the GUI. And then on the device side, this shadowed green means we are working on them. They are not on GitHub yet. So the Raspberry is available. We have Python with which we developed the agent which enabled the device to speak with the platform, and we are reporting it to Udo too. I don't know if you know the beautiful Italian board. And there was a talk this morning at 9 about MicroPython, which is a porting of Python for microprocessor, and not all the standard library has been ported because you have to do a lot of work. But we plan to have a porting of the same agent also for MicroPython, opening the integration within this platform for devices which run not on an operating system, but straightly on a microcontroller. And there are a lot of beautiful chips running already MicroPython. So you know, you have all of these kind of things, and maybe you say you are a GUI expert and you want to improve something on the front-end side, and you start up this development environment, and then you have to speak with this one, and you have to configure the IP of Nginx to speak with this one and to proxy the calls. Then you have to set up an OpenFire, or maybe we say, no, for OpenFire use it the one on the cloud, so you have to to work, you have to be on the internet. Maybe you are, maybe not. And so the solution was just have a complete Docker Compose actually solution that starts from scratch as soon as you have cloned, as soon as you've done a fresh clone of the GitHub repositories. And another choice was that each of these building blocks are different Git or GitHub repositories. So we have to take into care the fact that each of these building blocks must in some sense be independent from each other. So we have to be very severe on the protocols which allow us to connect all these building blocks. Okay, now for the demo. Okay, this is an online version of Iottly we have produced precisely for Python 7. Here we have our IoT setup, very simple IoT setup, but anyhow, it's a real IoT setup. So we have a Raspberry Pi, and we have a breadboard with a motor, and with two LEDs. One of them is switched on, and one of them is switched off. And here we have some projects. Now we go through the demo, and which is prepared, and then we will play with the code and do some things to let you know how is it going. So you start with the devices panel here. So okay, and the device panel says that my Raspberry Pi, which has this MAC address, has been registered within the server, within the platform. To register another Raspberry to the same project, so the hierarchy we've chosen is that you are a user or you are an organization. Within your user or your organization, you have projects, and within projects you have the code that you want to be run on the devices, the list of devices, and an admin console. What your board must do with respect to some important keywords. So let's say status. And you can say that status is multiple choice and is on and off. And you add the key. Then you say, let me choose a LED, so you have number, for example. And this is again a multiple choice, and this 1 and 2. Then you save the message. And you have this one, LED demo. And this is we use JSON, but we don't constrain it anyhow the payload of JSON. If you use any sort of already beautiful, also existing cloud IoT solution, Amazon AWS IoT or Microsoft Hub or whatsoever, there is some level at which if you want to achieve some functionalities, you have to respect some payload for the messages because they constrain you. In this situation, you are free to define from scratch all the functionalities. If you want that a particular message will reset the board, you just define it and then what happens is that in the firmware code panel, this LED demo we have defined in a second ago, auto generates a skeleton of code with some comments which help you in developing some very basic functions. And now, of course, as I showed you before, the board doesn't know anything about this. But since the code that has been generated here is already makes sense for the board, we just programmed by default to send us back the same command we're sending, so we test that the communication is correct. So we flash the code here. The code has been sent to the board. And hopefully the board restarts, and the loaded firmware is this one. Now it does not anymore complain about the missing loop and missing init functions because they have been loaded. And now if I send the command we have already just defined, yes, 1, 2, of course it doesn't happen anything apart from the fact that we are echoed back with the command. what we did, another thing, sending the code, of course, I prepared the code before just not to make mistake here. We have a motor code here, which says if the state is on, and it gets the motor pin mapped. I don't know if you know about PWM, which is pulse width modulation, and we can control the speed of a motor just sending some serial protocol over there. This is properties of this GPIO library for Raspberry Pi. Of course, here you can define whatever import or global functions. For example, here, let's say, after here you have all the definitions. So we are defining that the GPIO 7 is set up as an output, and then it is set up as a pulse width modulation with frequency 32,000. And what happens here is, hopefully, that if I send the command motor, I have to, not this one, sorry. Okay. Let's say command motor on, and I set the speed to 30. Okay, there is a delay because there is Wi-Fi from the phone to my PC and to the screen. So, and I can just change the speed. Maybe you can hear the sound if you are very, very silent. Don't hear it. You can also try to connect to the same address and control the board, and you can switch it off. And this you can say that you can see that it's been switched off. Now, let's pass to a more tricky example. I mean, these are all things that we can do communicating among the board and the user, which is me. This panel, I mean, it is not what we imagine we can give in the end of our customer, of course, but it is very useful to try out immediately what you are doing. One thing that I didn't mention in the design of the architecture is that there are APIs. All the things that we are doing from these interfaces are done by means of a REST API on the Iottly core. And this API is completely controllable from whatever other sources. So another interface, user interface, or you can automate firmware build and firmware sending to the devices, for example. But let's see, we were talking about if you have a high frequency signal on the field and you want to use it there because you cannot just transfer it here. Well, we have this SM bus permit us to manage an accelerometer, which is this one. And in fact, when we sent the code, we already sent something prepared. You have the loop function which polls with this frequency the state of the accelerometer, just getting y and x. And y is the value in g coming out from the accelerometer, and it sets the intensity of the LED, always with the pulse width modulation, of LED 2. So the 2 is because it is this one, I cannot. So back to the Raspberry Pi. Sorry. So hopefully again, if I start rotating the accelerometer in some direction, okay, you can see the brightness of the LED changing. Okay. So this is something happening completely on the field, not with a communication. What is important is that in the same way, if we have decided that our function need also to control the motor with the accelerometer, we change our code, we flash it again, try to switch to the other window. Okay. The motor started because of the position of the accelerometer, and now if I go this direction, the accelerometer, the motor stops, and if I start going this direction, the motor starts. It increases its speed like an accelerometer, because it is an accelerometer. What is important, the lesson learned from this demo, is that we are in complete control of what the device is doing, even if we are not connecting it. I mean, now, I think you believe it, but I mean, we can just exit the SSH console. I can disconnect no, I cannot disconnect the board from the internet because of course. No, I can disconnect the board from the internet because the firmware is already there. I cannot anymore control it if I do, but what is happening now continues happening. Okay. This was for the demo. There are some interesting things, like let's say I comment this line just not to discharge the battery, and I send the firmware again. The firmware runs, of course, is Python. We have some sugar from Python. But what happens is that if here I put something nasty, so a equal 1 over 0, I flash it again. Okay, oops, division by 0. So the firmware runs in a sandboxed environment, and you get feedbacks just like as you would developing straightly on the board. This is important because you can put your device remotely from you in the field where you have the real data, where you have the real sensors installed, but you can just try out any kind of hypothesis that you want. I mean, the sandbox environment maybe is not definitely, it is complete, but maybe it needs to some debug at this point in time, but this is why we are opening the solution to the community. And okay, just the last thing I want to let you know is that for development purpose mainly, we have another kind, these are, okay, this doesn't work, of course. We have this dev Docker device. What is it? It's a Docker container you can run on your local PC, which behaves exactly like an empty device. We find it very useful to test the platform. I don't know if it can be used to produce any kind of real IoT. Maybe yes. You are in a situation where you want to collect data from devices which already speak over the Ethernet, and maybe you don't put another hardware, but just a container running and collecting this data and then shipping them to Iottly. But this is done specifically for us developing the platform. You can run 1,000 containers simulating 1,000 boards connected and looking at what can happen. So you give a name, Docker demo, and for both of them you can send the firmware, of course, to one of the two boards. And the one ending with 9.3, just remember. 9.3, this one. Okay, this is not connected, this is correct, because being this a development device, there is no system D or supervisor D running. You have to restart it manually for now. But now you see, found firmware, some firmware found, and the board is connected. Of course, the network is missing just okay. And say the same thing we were saying before, and you can play. Keep in mind, we are on the cloud, and the device is running in a console on my PC, so it is on a very restricted, it is behind the phone, so it is on a very closed network, so it is a good simulation of what can happen in a real case situation. And here is the echo of your comment. Okay, this concludes the real demo, and Now it is time to pass over time. -5 to the question time or to the question time? Okay, just for reference, you have some description of technical insights of the project here. Just skip them, leave them. Okay, we were talking about distribution. And distribution can be just a name, because if I tell you, okay, download just clone the repositories from GitHub, and then you have to take 10 hours in setting up all the kind of configurations, it would be nasty. We worked hard indeed to make so that it is very easy to produce a completely new developing environment from scratch. So I want to demonstrate this to you. Okay. How can you do? Well, first of all, I hope that on GitHub you have enough documentation. But anyway, these are all the projects on GitHub. If the entry point for all of these projects is Iottly Docker, where it's documented how to start up all the infrastructure. The first thing to do with this helper script, either you clone all the project, or you use this helper script, clone it. Okay. Where? Sorry. Of course, time. First one. Okay, now it's cloning all the things. While it is doing this, Iottly core, which is the core, in fact. Any project is configured like this. You have a Docker level with a Docker file and all the things needed for the Docker file. You have the project itself, in this case all the Python requirements. And just to let you know, this is the configuration file, and all these kind of configurations are already being resolved for the standard setup on your laptop in GitHub. Of course, a lot of these configurations should be changed going on some kind of production or other, but okay. Now, the first thing to do is that since we use AngularJS to develop, you have to go to the console and build all the Angular stuff. I don't know if you know AngularJS in some way, but you have an NPM, you have Bower, you have Grunt, and a lot of other stuff that I don't know so well. And in fact, this is the reason why a container starts with this command. The container download the NPM from GitHub, and then I mean, this is not a Docker talk, so you go into the two projects as it is documented, and reinstall. Now Bower JSON white. Of course, everything went the right way up to now. I know Iottly console, sorry, Iottly project it is. Okay, here we are. takes care of downloading all the requirements for Angular. You have to do this twice because, as you may have understood, you have two kind of Angular projects, one for the main page and one for the project control one. This will take some time, no, not so much, and again on the other. Okay. Okay. Now, with this script, you just inject the local IP of my laptop onto the architecture of Docker. All the Docker infrastructure is coming up. This is Docker Compose, essentially. Just to wait for any of the services to come up. You can see you have the database, the user interfaces, the core, some volume which serves as repositories for installers, certificates for the security. Of course, does not store our production certificates, but I think it is a good practice to put on GitHub how you are managing the security settings. Then, of course, everyone has different settings, but it is there to be used. I mean, we are not just saying security is important. We work it with Let's Encrypt in case you are interested. So now the infrastructure has been started, and here, okay, we are on localhost here. You can create a project quickly. You can create both a dev device, or if you have a Raspberry and you want to play with that, also being local. Now the address, of course, is not secure, and the public IP, the simulated public address of my cloud application is my laptop local IP. But if I run here, if I run as before, thank you. Copy, as usual, the installer command. It's started, and it is registered here, and it is connected, and you can start playing with the commands. Of course, the function echo is not recognized because you didn't send the firmware. You can send the firmware as before. And, started. I think we will add some kind of supervisor also in the container because it is quite annoying. And you are up and running, but take into account that you have run 7 services and remote devices, and you are on your local laptop to test an entire IoT ecosystem. This is why we call it a distribution, because we want it to be for you, for the community will, we hope, join the project. So to come to the end of the presentation, the roadmap. Here is what we think about continuous integration and delivery in the IoT world. We cannot call what we have seen a continuous integration, a complete continuous integration solution. It's just an easy way to transfer your code to the device, but it is a step in the right direction. What we want to work on is just like a drawing like this. You have a master. We are working to add the Git integration with Iottly. not GitHub, in the sense that maybe you can just connect your GitHub account to have the source code for devices stored and versioned on GitHub, or you can have your local Git repository or your cloud Git repository by yourself. And you have a master branch for your device code, and every time you click on the flash button, the firmware is built from the master branch and sent to the production devices. Working with Python at this stage, you don't need to build anything, of course, but we are taking into account always with container, all the sorts of problem coming up with cross-compiling C code for ARMs or other fun processors. Then you have a branch new feature for the devices. You declare some devices on the field, maybe also in your laboratory, but it is important. You ask some customer, you ask one of your three of your customers to use their devices to test some functions, if you can. Otherwise, better you find somebody to do it. It is an absolute best practice in IoT. Then, since you have defined this as a testing board, when you make push the flash button on the console, the firmware will be built from the branch new feature, and then you have some quality assurance on the Iottly side, in which you can define the tests, and if the test passes, you can merge into master, and the new functionality is ready to be shipped to devices, so that you can also automate the process of upgrading firmware with latest build, which are on master. I mean, there are a lot of policies. The policy we are choosing is that master is always deployable, in a continuous integration scenario, and you make whatever you want on other branches, and you can and you should as board so to test the features. This is the big picture roadmap, and we had a lot of work to do. We have to, we do not implement REST HTTP for the board for the moment. It is not very interesting. Between REST HTTP is monodirectional. You cannot send something unless the device starts calling to the server, which is not a good paradigm if you have a lot of devices. So, but we know that some customers, some use cases like to use REST, so we will implement it. COAP is a constrained access protocol for very low power devices, which is important to take into account. And then we will introduce message queues within the main architecture to make all this stuff scalable from scratch. And custom logic flows, we will integrate Node-RED. I don't know if you know this beautiful project in Node.js, which is a platform, a graphical tool with which you can build logics. Server side, I mean, there are people which installed Node-RED onto Raspberry Pi, but you have to be on the local network of the Raspberry Pi. We plan to integrate Node-RED server side. Maybe say when a device sends a message, you want to send a tweet, or you want to send an email, or you want to do something that we do not want to program everything in the platform. So we will ship this sort of integration. We will produce some mechanism for API publishing and webhooks. So if you register a third-party application within within Iottly and a device and a message, the webhook on your application will be called, and things like that. You can find it. And important, we are going to develop some C. We have some C code for microcontrollers. We have not yet published it because we have to refine it for the microcontroller not running Python. If you are interested, you can find any kind of details in this page of TomorrowData. Thank you. I've been quite long.
Okay, but there is still time for one question. Okay.
Hi. Just one quick question. Once the the device is registered,
Yes.
getting the wget command, and which is the communication between the server side and the client side? Is it WebSocket based or something else?
XMPP in this situation or MQTT?
Oh.
I forgot to mention.
Okay, thank you.
This one. XMPP in this situation or MQTT? XMPP is the protocol, the Jabber protocol, chat protocol, but it is widely used in these situations. It is based on XML, streaming XML. And MQTT is a telemetry control invented by IBM some years ago, which has published subscribe parity. Correct.
Any other questions?
Hi.
Hey.
How would you handle offline situations? I mean, is there any queuing?
Yes. Yes. They will be managed on behalf of the platform itself once we will have the message queue inside. We are doing tests with Kafka. I don't know if you know Kafka. Kafka has a lot of wonderful functions about retention policies of messages and gaining back messages with counters and things like that. For now, we rely on XMPP and MQTT capabilities of doing just like things. So in the demo, I think, if I go offline here and I send a message, this is the local one, it's the same. Hopefully, I don't know. If I send a message and I start it again, you see the message when the system is started up because XMPP server is doing the caching, the buffering. But we plan to move this kind of properties within the platform with the message queue, because you have a lot of situations that you cannot rely on the broker's position on the broker side of your ecosystem. Maybe the database is down, you know.
Okay. There's no more time for questions, sadly, but thank you, Stefano.
You're welcome.
Just a couple of notes before you leave. I want you to remember that if someone of you has to do the checkout from the